In this video, we will use Taylor series expansion to generate the dataset for these x values. We use the formula series sum x to the power 0 incremented by 2 and this coefficient. The coefficient will have this formula 1 over square root of 2 times pi times negative 1 to the power n all over 2 to the n times n factorial. The values of n will start from 0 to infinity, but in this case, we'll just limit to our data set. So we begin with the calculation using the denominator, which is RA formula. 1 over that is 2 times n factorial. 2n, 2 to the power n times factorial n. So our n, the denominator should be covered. So that's the denominator part. Now we go to the numerator part. So 1 over square root of 2 pi times negative 1 to the power n. So we start with the negative 1 to the power n minus 1 to the power n. So we have alternating signs now. That's because of the negative 1 to the power n. Next, we factor in 1 over square root of 2 pi. So we add 1 over square root of 2 pi. That's 1 over square root 2 times pi and now we have the coefficient. Now we can use the series sum formula, which is RA formula, series sum x values starting from 0 incremented by 2 and these coefficients. And we chart this. We use the scatter chart and regress it to the best fit trend line, which is the polynomial to the highest power possible. We try degree 3, doesn't fit everything, so we try another higher degree 4. Now it's better, looks better. Try 6. 6 is perfect, so we have r squared of 1. And from here we can enter the normal distribution, which is RA formula, NORMDIST of the x values. 0, that's our mean. 1 is our standard deviation, and 0 because we're using the normal distribution. So you'll notice the series sum and the NORMDIST are on the same line. So let's add the equation, the trendline equation. Use the same trendline format. Polynomial raised to the power 6. And show the equation in r squared. We have the same r squared, and we have the same regression coefficient of regressions. Now we can add the phi function, which is our formula. Phi of the x values. Now it's still the same value. These two are exactly the same. Well, this one is the best, a very close approximate to these two. So, and we'll show the trendline equations. See if they have the same regression coefficients. Polynomial, same degree, degree 6, and show the equation and the r squared. Okay, they all have the same coefficient of regression, 0.396. That's for B0, B1, all 0, B2, negative 0.183, B3, all 0, B4, 0.331, 0.331, 0.331, B5, all 0, and B6, negative 2.16, negative 2.16 to the power minus 3, and this is also negative 2.16 power minus 3. So this shows the Taylor series expansion of this data set for that will match phi function and the norm test function of standard normal distribution.